So actually, no surprise, we had some communication before the conference to discuss what we are going to discuss in this panel, right? And actually we thought we just focus on iron ore, of course, on both the direct reduction end and the blast furnace end. We have Nigel with us, so we can also have the supplier's view and have the technology provider's view, let's say from Filippo and Alexander. Yes, we can, I think, stick to the plan. However, I mean, this is the last session of this two-day conference, and we've already heard a lot. So let's try to avoid repetitions as much as possible, and maybe try to, I don't know, we haven't agreed on this, but really, what are the most pressing issues you are seeing from your point of view? What keeps you the most busy? Let's say, what keeps you busy the most at work? What should the industry be focusing on maybe in the near term, in your opinion? Or what should we saw that this is not only about the steel industry, this is a value chain approach, or actually this is much bigger than this. This is the kind of a global economic transformation. So what should the global society be focusing on from your point of views? But okay. That is maybe a too much remaining in our realms, but still try to make it, you know, a bit more maybe also trying to synthesize the discussions we had over the 2 days. All right, so let's stick to the plan somehow, and Nigel, start with you. So from supplier point of view, from BHP's point of view, what do you see? Let's start with the direct reduction maybe again. But also, again, what are the most pressing issues? You mentioned you have this extensive portfolio, and maybe the biggest challenge is really how to prioritize and how to allocate your, of course, scarce resources over these different initiatives. Also, something interesting from Vale's presentation, they had this 6-stage approach to identify which of the initiatives to, you know, to implement. So, yeah, Nigel, microphone is yours. Thank you.
Well, thank you for that introduction. I mean, many things keep me awake at night, but I think what we come down to in our approach is controlling or playing where we can make an impact. And so when we think about the areas to focus on, and hopefully the discussion I had today emphasized that we can't control the hydrogen price, we can't control the timing of carbon price and how it will be implemented. But we can make sure that the technology options are ready for steel producers and they understand the pros and the cons and where the trade-offs need to be made in order to use different technologies at large scale. That's what we can kind of control. Even that, we're needing the partnership approach. In the meantime, we'll continue supplying the iron ore consistently, reliably, sustainably, and efficiently for that. So in our approach, it comes down to how we can play a role in the particular technologies and where we see the gaps when we're talking to our customers, not just in DRI, but also in the blast furnace. But in DRI, it's really that if we can make good pellets, the DRI will work, then there's no problem. And then we can slowly work on the electric smelting furnace to characterize how it operates. What are the trade-offs? And then we look at the more well-characterized performance in the electric arc furnace as a benchmark. So if electric smelting furnace doesn't work, we've got the reference of how the electric arc furnace or the blast furnace works, and can we do better than that? So these are some of the things we think about.
What is kind of the most challenging, let's say, obstacle you are seeing, you know, in the adoption of the pellets you are developing, or in the technologies that you are currently collaborating with some other parties? So what is you know, keeping you the most busy, and what are the, let's say, biggest near-term issues?
Maybe a couple of years ago, I would have said there was less appetite for this kind of change, but I think the appetite and the opportunity is really there at the moment. So I don't see that as a problem. But when I I guess part of it is finding good partners is part of that challenge. I'm not saying that there's bad partners, but you have to be able to understand your partners and what is their value drivers and how your collaboration brings mutual value. And so before all of the technical stuff, or maybe the technical things are criteria in that, but making sure you can have good partners, have open conversations, solve problems, but have some mutual benefit that you both see out of that project, I think is part of the challenge. Yeah.
Okay. Thank you, Nigel. And Filippo, Alexander, turning to you, maybe starting with you. Filippo, so what is the technology provider's opinion on this, and what are the most pressing issues, biggest challenges in front of you, focusing on the technologies you are trying to develop?
I think that in this phase that is so challenging, what is important is to have in mind, according to my opinion, is to get the capability to work into different conditions. But we have some levers that we can adopt to, let's say, adjust or to regulate our processes. Some examples. We discussed a lot about the purity of DRI, and we discussed a lot also about which are the most suitable melting technology, ESF or EAF. In our project, for example, we made a preliminary selection for the electrical furnace, but the experimental facility, in any case, already designed to host an ESF. We have to change the shaft for sure, but we have in mind also that the melting technology may change. But there are, according to the modified operating practice, I would say some boundaries of overlapping of the two technologies. And one lever could be, for example, the blending with scrap. And this is an important aspect. Also, and this is more important, we have learned this afternoon that the improvement of scrap quality and scrap sorting and so on is costly, but the advantages deriving from such type of activities are enormous, respect what you spend in terms of energy and effort. And so the blending of DRI and scrap could be a lever that you can use according to the quality, for example, the starting iron ore pellets. And another important issue is also, in my opinion, the capability also to modify or to adapt the operating practices. In this phase, I think that we have to come back to the laws of physics and thermodynamics without a religious dogma. So the slag of electrical arc furnace, the slag composition, and in some cases we are also trying to think improve the modification of refractories, because maybe these may support the utilization of different materials, and this may mitigate, let's say, the impact, for example, on the increasing slag amount. So I think that we have to get this capability.
Thank you, Filippo. Alexander?
Well, first of all, the biggest takeaway from the 2 days for me is that green steel is not dead. So I've heard over the past few weeks, and I was traveling a lot, from some people assuming that decarbonization might come to an end. So I'm really glad. So this was a big community, the whole value chain. And when I listened to all the presentations, panel discussions, also during the coffee break, I think there is definitely still a consensus that decarbonization is going on. So there was also a presentation today. It's not a matter if we decarbonize, it's about the speed of decarbonization. And well, that's a valid question, but we have to keep the train on track. That's the most important takeaway, and I'm happy that we all share the same view. What keeps us busy is definitely what is the headline of this panel, the raw material situation. And we've heard a lot all this afternoon around this topic, and I think this can be summarized with flexibility. Flexibility in iron ore qualities, grain sizes, type of iron ore, and this is all related to very regional topics, depending which mine, and it requires, as I said yesterday also in my keynote, it requires this close partnership with all the stakeholders around, So I appreciate really having the big mining shots here during the 2 days. Because at the end, it's always an individual case for a super huge investment. If we go for any type of iron making technology, especially direct reduction technology, well, we have to deeply investigate, is it better to beneficiate? Is it better to take the lower grade iron ores directly and processes in direct reduction and smelter technology? And well, then comes downstream the cement industry in place, because then it strongly depends, is the market there for the slag product, Like in Japan, Japan is exporting most of their blast furnace sands out of the country, which is not the case in Europe. So it's very regional, and therefore we have to allow this flexibility and the variety in different technologies, from the raw material source down there really to the end product. And this requires this immense work in strong partnerships.
Thank you. So out of this first round, the two buzzwords that I'd like to emphasize is partnerships, flexibility, and green steel is not that. I totally agree with all of the importance of all of these. And in terms of the pace of decarbonization of at least the steel industry, I don't think really we have slowed down. This is a long journey, right? And even there can be periods, where the process slows down, but there will also be periods where there will be an acceleration. So I think we should also agree with that. So let's continue with partnerships, shall we? I think you all have by now a good experience with partnerships. So what are the key elements to success for the initiatives that you partnered up with other parties regarding steel industry's decarbonization? Nigel, shall we start with you again?
Yeah, sure. So I guess building on what I said, having that mutual interest, shared interest in a common goal is important. I think understanding each other's contribution. Mm-hmm. So for us, actually, it took some time to establish this. What is your role? You sell iron ore or coal. Why are you here talking about technology? Mm. And really, we had to think about what is our contribution here. We have some funds we can invest. We can't just build DRI plants for everyone or something like that. But we have some funds and they can help. We have some information sharing mechanisms, which helps not just our immediate partners, but the broader industry. But we really had to think about that value proposition. We're not trying to monetize technology, that's for other people. We're trying to sell iron ore. So we really had to understand what we offer to the partnership and how we can play a role. And each partner has to bring something to that role. Otherwise you find that there's some struggle or some tension that builds up as well.
Thank you. And Filippo, can you also comment on this, the key elements to success for decarbonization partnerships?
For sure, partnerships are essential because it is not simply an exchange of experience, and in case of hydrogen, it's not just, let's say, taking out one gas and introducing another one. So it is a complex situation, and a lot of competencies are necessary, and a lot of point of view are necessary, and in order to find out which are the best technological solution, the best operating practice, it is important to have. This is an occasion, for example. And I'm a European, so I have with me on my shoulder the experience of the European funded project in which we are used to discuss also among competitors. I don't remember who mentioned that we are competitors, but we can in any case exchange information, in any case learns from each other. So, and this is a global problem for sure. So, and even if we outlined that there may be different solution according the specific local situation, but in general, the way in which a process is managed, the way in which solutions are adopted, and also discussing with some colleagues, they told me that, for example, I mentioned the test on refractories, and they told me that they had some experience which were positive. So this is a nice point to avoid to repeat, which are consolidated results. And okay, let's start with studying from what is relatively new, so we can save time, we can optimize, we can save energy, and we can improve the overall results. So for sure, it is another important aspect. So circular economy, it's a recirculation of materials, but maybe it is also, let's say, a circulation of ideas, and technologies, and so on.
Thank you, Filippo. Excellent. Alexander, would you like to comment on the partnerships?
Yeah, I think key for any type of partnership, private life as well as in business, is to understand right from the beginning, this has to be a win-win for any party. And that's important to define and to provide these borderlines right from the beginning. Meaning it has to be clarified about the IP rights and how the cake is finally distributed. That's all about the partnership. And I think if these pillars are clear and there is a clear win-win and everyone is treated fairly well in there, it will become a success, because then you have the diversity in there from the different fields I've not mentioned before, but we have also the big players in the gas sector here with Linda Ehrlich-Keith. They play an important role as well, because usually steel producers are not producing their gases on their own. So there's a long-term offtake agreements, the same for the raw materials, and at the end, offtake agreements for the products. So the OEMs, technology providers, have their role. Their interest is clearly, well, to play out their card and their strengths on the engineering part, on the supply part, also the knowledge in how to install, how to commission these plants. So if everyone really utilize its strengths in the partnership, it can just become a success.
Certainly. Well, green steel decarbonization, decarbonization of the steel industry continues, in my opinion, at a rapid pace. But we also see blast furnaces will be with us for a considerable period of time. So where are we in mitigation of blast furnace emissions? And where do you think we will be in 10 years from now? How a blast furnace in 10 years from now will look like? We all know maybe the answer. Yeah, it will not look like the same as it is now. But you know, what is your vision? Maybe I can put it like that. Nigel gave kind of slides showing BHP vision, how the emissions of blast furnaces could be reduced. You presented certain levels. So what is your view on this?
Yeah, I think it builds on those views that we'll continue to see increased efficiency. Like I was saying earlier, that some of these are cost positive kind of projects. They can make money with a bit of investment, add productivity, reduce energy, can add up positively. We see there'll be, I guess in specific terms, maybe a trend, particularly in China, towards the higher pellet ratios in the blast furnaces. There's already the installed capacity. There's already the references within China and elsewhere of using high ratios of pellets instead of sinter. And so we've got to be prepared to show how that can work for our iron ore products and the others that are utilised in the blends. And I sort of touched on it earlier, but the journey that we went on with our Australian find was a long one, starting 50 years ago or earlier with the Japanese steel mills, and then with the Korean steel mills, and then the Chinese steel mills, on how to use the products that are available in the processes they have to make the operation competitive. And we see that the same thing will happen through the evolution of the blast furnace next. And maybe that role of pellets, and of course we also like to look at iron ore lump. It not commonly used easily in the blast furnace, but then steel mills in Japan learn how to blend it better and utilize the availability of it in the burden, and we see more potential in China to do that, to increase the lump ratio, but have some more techniques for reducing the fuel penalty that potentially can bring as well. Cleaner lump with innovative screening, pre-drying, maybe even pre-reduction of the lump in simple processes can help create a low carbon burden for the blast furnace.
Thank you, Nigel. Filippo, yeah, what's your view on the future of blast furnaces?
I think that blast furnace is a fantastic reactor because it is very efficient and let's say it's a solid, it's a robust reactor, and we know that the blast furnace which will continue to survive will be let's say improved and modified or respect the ones that are under operation now, even if already now there are relevant examples of blast furnace with reduced carbon footprint. In any case, this means that also for blast furnace there will be application of breakthrough technologies, and because in any case the process is going to be transformed in order to reduce, for example, the coke demand. And we always speak about CO2 emissions, but if we reduce the coke demand of the blast furnace, we are in general reducing the environmental impact of the primary iron making, and this is an important issue. And there are also some, I would say, intermediate solution. For example, one is to have the installation of a DRP shaft furnace close to a blast furnace in order to replace part of the burden with already produced DRI, so you can manage for, I don't know, 10, 20 years the blast furnace in some way, and you are 1/2 prepared to the transformation and production cycle. So it's from my point of view, and we had strong confirmation within our conference in these 2 days that the blast furnace will be transformed and will be suitable for decarbonization, and with some intermediate technological improvement, some way will prepare, let's say, the road also to a complete transformation of the production cycle. So I think it's another interesting option. It will depend, again, on the local situation. The first one is the age of the plant.
Excellent. Thanks, Filippo. Alexander?
Yeah, I do agree. First of all, blast furnace is a wonderful facility to produce iron, and it will be difficult to outcompete blast furnace. But, well, unfortunately, it's emitting a hell of CO2, and it's similar. Ferrari is a nice car, yeah, but is it appropriate to buy a new Ferrari in this time if we talk about decarbonization? Not sure. So, well, I think we have to distinguish two different cases. The one is there's a large fleet out there of existing blast furnaces, and Tom Bögel showed also the life of or life distribution around the globe of the blast furnace fleet. And we all agreed over the two days the blast furnaces will stay around. But then we are talking about these blast furnaces, they are already in place. Yeah? So when I say distinguishing is, I have a very clear opinion. Yeah? Decarbonize existing blast furnaces, but don't go for any new blast furnace investment. Yeah? And that's also where Primetals is positioned. So we support any efforts to decarbonize the blast furnace fleet, but not engaging into new installations. we leave it with others there. So I think we've heard many opportunities how we can decarbonize blast furnaces, and we should definitely put our heads together. I mean, Nigel was referring to the high growth. It's, I think, incredible. Even I have no proof, but I can't just believe the figures we see. I mean, 30% decarbonization of an existing blast furnace is incredible, just I have to say. Yeah? And yeah, well, there are some more crazy ideas around how we could even go further. So let's do that. And I mean, at the end, there's always the option of carbon capture for any of the facilities, direct reduction as well as the blast furnace. But then we end up what to do with the CO2, and we are missing the infrastructure. And not all the countries and governments are still or are supportive for carbon capture and storage, at least.
Thanks, Alexander. Shall we try adding the energy dimension to our discussion? So I understand low carbon energy, low carbon electricity will remain scarce in most parts of the world. Yes, there are some unique locations where there is some, let's say, abundance of low carbon energy. But even in those locations, I think the debate has started how to allot the green electrons for that purpose or for this purpose. So why don't we export electricity, for example, instead of producing green steel or green something else in this country or in that country? So assuming that this will also be the situation in 2040s, scarce green energy availability, and we also see some of our projections now suggest a scaling up in 2040s, which means our demand for green energy will be showing growing or strong growth in 2040s. So, and we'll be competing basically with many other energy use cases coming from buildings, coming from transportation, coming from everywhere, also from manufactured goods and so on. So taking this, let's say, risk into account. So can you provide your view? So should we consider certain business models taking this risk into account? Yeah, Nigel, do you have a view on this?
Maybe. I think it comes back to the same position I shared earlier, that we should make the technology ready, and then when the source of the electrons change or the source of the hydrogen change, the technology still works. But not wait necessarily for the sort of end state to materialize before doing anything. So continue on that path of steady decarbonisation, steady progress of technology development. And when the economics and availability of renewable energy are supportive, then everything is ready. And you can make economic decisions at that point.
Yeah. Thank you. Certainly true. Yeah, Filippo?
It's a matter of fact that there will be an increasing demand of energy and green energy. And even if, let's say, reminded the aspect related to the improvement of blast furnace, if we are going to reuse the blast furnace gases, we are going to take out some fossils for energy production, so we have to replace the energy that will not produce anymore with the blast furnace gases with another source. So it's whatever will be your idea and or your technological solution, you need energy. And so first, activities related to the improvement of energy efficiency are even more important due to the fact that the energy demand will increase. And we have seen also for combustion, the adoption of oxy-fuel combustion or other solutions. So this is fundamental. And it is also, as we said, we have several technologies. The same is for energy. So I think that we do not have to, let's say, get in love with a single energy source, but from my point of view, for example, the word nuclear is not so bad, but I know that this is a very large debate, but we have to understand that the increase in demand is an enormous number. If you are used to manage those numbers, if you made some very rough calculation on a paper, if you take your annual production of steel, you convert into new production route, you just multiply for energy production and so on, you are afraid of the number that you will get, just with a calculation of few minutes. So it is important, let's say also that the energy solutions should go in parallel, because otherwise it's difficult to decarbonize the steel production, but also this is the same for the other production, for the other technological, for the other hard-to-abate sectors.
Thank you, Filippo. Alexander, what's your view on this?
Well, maybe sounds a bit radical, but I've positioned far right talent here on this stage, so it's okay. Huh? Well, my opinion on low carbon electrons is clearly utilize them very carefully and in the best way. So I'm not a strong promoter that we use green electrons or low carbon electrons in a way that we produce hydrogen and think then about utilizing hydrogen as a fuel to burn. Even our company developed hydrogen burners and so on. But I would think this is the last option, to fire hydrogen. It's simply crazy. It's such a rare molecule, and it should be used for reduction purposes. It should be used in the chemistry where there is no other option to replace gray hydrogen, but not to burn it, neither in any turbine, nor in a burner, before we have sufficiently the hydrogen available. And the other thing is, I'd like to amend here is clearly when I listened also to Wali's speech on the shipping. Yeah? I think iron is the best form of an energy carrier. We should not think about shipping hydrogen or green ammonia or any liquid organic carrier then to decompose it again back to hydrogen. Yeah? Let's use the electrons and the hydrogen where it's produced and produce simply a more added value product from the iron ore, producing DRI, HBI, and pig iron, and ship this one to the location where it's needed for the steel production. This reduces simply significantly the number of ships that going around, and it's the best form of shipping energy around the globe in a safe and reliable manner.
Thank you, Alexander. Well, let me turn to our participants and ask if there is any question. Yes, Jeremy, please, go ahead. Microphone is there, yeah.
So, I'm going to kind of set up the panel a little bit first. So everybody believes in sustainability, right? And everybody believes in circularity, right? But we're going to keep using blast furnaces. We're going to improve the carbon footprint, but we're going to continue to consume virgin resources. And then our scrap supply is expected to increase by a factor of 3. And people said, well, but don't worry, we're going to use more scrap in the BOF. But the only way to use more scrap in the BOF is to increase the carbon footprint of the BOF, because you have to use ferrosilicon or calcium carbide or some other source of fuel, burn it in order to have more scrap. So now that I've presented that, how do you figure out how to solve this dilemma? Because we need to consume that scrap. We can't just make millions of boat anchors.
Jeremy, you want to direct this question to one of our panelists specifically?
No, I think it's good for all of them because they will all have a slightly different perspective, I think.
Alexander,
Yeah,
would you like to
let
take
me
this?
start on that, Jeremy. Yeah, much appreciated. Yeah, so maybe we missed out to talk about scrap now on this panel, but I think there is simply no doubt that we are going to use any kilogram of scrap, which the increasing amount or volumes of scrap over time we are going to use it. But if we as we have seen on all the forecasts in different presentations, well, at the end, it will be equally balanced, 50% scrap, 50% virgin material-based materials in 2050, plus minus. So this means we still require a significant amount of virgin material-based based iron, but we have to use the scrap. And regarding your message on increased scrap rate in the BOF, true. Well, we have even the IP on the jet process. You might know it, bottom blown or combined blown converter with hot blast from the top. So, well, we have tested this at POSCO at large scale BOF. It's easy to go to 50% scrap rate with that, but it requires carbon injection, and, well, it requires hot blast, and the hot blast has to be heated, no doubt. So that's increasing the carbon footprint.
Yeah, no, I'm familiar with that. My friend Christian Gunther was involved in those trials in POSCO. Yeah, I just think that there's this thing with the balance, because if you have close to, say, 900,000 or 900 million tons of obsolete scrap, first of all, very important to know, instead of just calling it obsolete, we need to start to actually have better clarity. Grade 1 obsolete, grade 2 obsolete, with respect to the residual levels. That then inherently implies what level of OBM needs to balance with that in order to make a certain product. Does that make sense? Yeah. So, yeah, I think we still have to do a lot of thinking. And I love to look at 2050, but I think sometimes people focus too much on 2050 and not on what happens between now and 2050. So I think sometimes we have to sort of step back and look at the path that we go on.
But if I can complement just 1 minute, I mentioned the scrap as one of the levers to use to allow, for example, the utilization of a lower quality material. And I mentioned the good quality of the blast furnace, but I'm the scientific responsible of a project which is centered on DRI and EAF, and I like very much this new production route because it is a flexible route in the sense that at the end of the day, what is dominant is the quality of the steel that you are going to produce, and looking back, based on this requirement, you can decide how to manage your electrical furnace, and basically you can have also iron produced by electrolysis, which can be entered into the mix of the electrical furnace. If it is almost pure iron, you can have 10% of pure iron and the remaining from scrap, but we know that also quality of scrap is increasing, and so I think that it is a stepwise process for sure, but I like very much this wave of the possibility that the electrical furnace gives in terms of integration of different possibilities.
Yeah.
Thank you. Shall we?
So I think one of the things, so at the same time, so the electrolysis part, yeah, I get it. I'm involved.
It was an extreme example, just to mention the possibility of this technological route.
But we also have to understand that if we don't gain a better understanding of the scrap, it takes typically, in the best case, 3 years to 5 years to implement a new project to produce OBMs, which means that we have to see out into the future at least 5 years in order to make decisions now that will be the right ones for 5 years from now based on what the mix is that we have available. So I just think that I just don't want us to oversimplify things and then go through this sort of seesaw process, because we kind of did this with DR grade pellets. We had a surplus, we had a deficit, we had a surplus, we had a deficit. Every 2 to 3 years, we have this cycling, and we track this within IMA, and it's incredible. And so you want consistency within the steel industry. You don't want a lot of volatility, I think. I don't know.
Let's try to get one or two last questions. Joachim, please.
Right. Thank you. It's a very interesting discussion. There is a global reality, and the global reality is that there are more blast furnaces being built than blast furnaces being shut down. And if I'm not mistaken, there are more blast furnace capacity being built than DRI capacity being built as well. However, when we look at us, global steel people, we put an enormous amount of efforts into something that is, we're trying to shape the reality, but the reality has its own life to a certain extent. And we had great examples of what we can do in the blast furnace. I don't want to put a rhetorical question, it's something to elaborate. Aren't we somehow putting too much effort into things that is not happening, instead of addressing all these efforts maybe into shaping the blast furnace with examples that we could reduce the CO2 emissions by 30% in the blast furnace, combining that with carbon capture instead of all these things? Well, I spend time with hydrogen, etc. Or are we kind of fooling ourselves a little bit here? Or should we try to rethink a little bit and adapt to the global reality? Or should we put even more efforts into then shaping the reality in a different way than it has taken? It's a big question. Please.
Yeah, appreciate, Joachim, this provocative question here. Well, we're first of all to acknowledge that there's a different level on the developments around the globe, yeah? And well, developing countries claim their right also to grow in steel or any basic material that is required to improve their life situation in the future. Yeah, but I don't believe that we should promote new blast furnaces, because this means new coking plants. Yeah? And if we see on environmental permitting and all these issues, I don't believe it's the right way. But we have not arrived at the point where new blast furnaces are not a viable option, I have to say. So we've seen so many developments ongoing, how many demonstration plants at big scale, such huge investments, and simply it takes a couple of years. So we've seen 27, 28. I think that could be a turning point if the first smelters are there, fluidized bed technologies, CC carbon capture implemented in the iron making, all these things, new generation of electric arc furnaces and so on. I think in 3 years' time, maybe it's the right timing then to come back to this question, Joachim. Yeah?
Excellent. Okay, we are over time again, so let me try to wrap up this discussion. So first of all, decarbonization of the steel industry continues. Secondly, we can't wait. We need to develop the technologies, the low carbon technologies. So, and we should start mitigating our operations, the current operations, right? We cannot wait them to be deinstalled. And lastly, maybe we need flexibility. Yeah? We underline that. We need these new solutions to be flexible. So thank you so much once again.
Thank you.
Any final?
Thank you, everyone.
Okay.
everybody. I stand corrected. I said it wrong. Some of the presentations are already there on the website. So if you visit worldsteel.org and Breakthrough Technology Conference section, you have got day one presentations already there. Together with the photos which are available on Flickr platform. And by the same extension, today's presentations will also be there, probably by tonight or maybe latest tomorrow. Can't add much to what has already been said, but I will just give thanks to everybody for their great contribution. I cannot stress the importance of having all different actors, parts of the value chain in the room, because it should not become an echo chamber that we just talk to each other only within the steel industry. And I'm pleased that we had the upstream side, the steel makers, and even part of the downstream. And we try to optimize only or minimize scope 1 and 2, but scope 3 is somehow shared along the value chain. And unless we work in a system-wide effort, things are not going to change. I am very positive and glad to have met some of you again the second time, and I look forward to seeing you the next time. And I would like to invite Edwin Besson, our Director General, to say the closing remarks. So from my side, thank you.
Thanks, Rizwan. At the opening remarks, I started with saying thank you. I think I should do the same thing now and just say thank you to all of you that are still in the room. Thank you for spending lots of money and lots of CO2, by the way, also to come to this discussion. I also said yesterday, I am optimistic about the process of decarbonization, and I'm optimistic about the process of decarbonization in the steel industry. After 2 days of discussion on all of the topics that matter, you know, we dealt with demand forces, we dealt with energy, we dealt with gases, we dealt with raw materials, we dealt with process technologies. After 2 days of that, I must again say, I am very, very optimistic that this industry is going to go forward. My sense about this conference, compared to the one two years ago, is that this one is a lot closer to the workplace compared to the other one, which was much closer to the talk shop. So we have moved in 2 years from the talk shop to the workshop to a large degree, and I think that process must continue. I found the last panel discussion very, very interesting. I think we are approaching a turning point in when we have to start promoting new technologies and new approaches. In that respect, one thing that struck me over the last 2 days was, if I remember in Abu Dhabi, the term ESM was probably used once. It was used many, many times now. So the turning point discussion, I think, is already beginning to take place, and we should see where it is leading us. Overall, therefore, again, just thank you, Rizwan, to you and the team for arranging this. Thank you for the support staff in the room. A conference like this just does not just happen. It happens because there's lots and lots of preparation work before the time and lots of detailed planning. I'm very happy that it has worked so smoothly. That's maybe something else. We can pat ourselves on the back as an industry. If we did this thing 5 years ago, none of the presentations would have stuck to the time. Now, 99% of the presentations were in time, were focused, and provided just the information that was required. So, congratulations to all. Thank you for your contribution and your participation. We have said all along, we'll review after every one of these conferences, is it necessary that we have another one? We don't want this to turn into Shrek 3 and Shrek 4 and Shrek 5 like the movie, where the story is the same, it's just the same thing. I think after today, my feeling is we have space for a Shrek 3. We will figure out where it is going to be. It should be in 2027, and we will inform you in due course about where it will be and what the situation will be. Thank you for being here. Travel back safely, and decarbonize where you are in the next 2 years as well, till we speak again. Thank you.